Hello, hello. Ciao, Teo.
Hello, Luca. Ciao. How are you doing today?
Not too bad. Not too bad. A little bit not congested, but back from a flight, and I need to drink sometime my tea to keep my throat
Ooh.
sane. But for the rest, everything okay. And as you can see, I haven't had time to print the picture for
No,
the both
not
of us,
yet. Duh.
but I
I
will do
can't
it this
wait.
weekend.
Oh
I
no,
will do
you.
it this weekend.
Yes, because in a few weeks we are going to meet, and I want my T-shirt. Okay.
Oh, it will be done for sure. I'm gonna do it this weekend.
Okay.
And also, just one quick reminder, maybe for everyone that is listening or viewing us, you need to comment something with meaning in one of our channels, and we will make sure to then select from all the comments one winner every week, and we will connect with you and make sure that. This person will get our custom handmade podcast t-shirt.
Wow. And
Yeah,
look, I took an haircut. You didn't see. Come on.
no, I noticed,
I also shaved
but
a little bit, shortened a little bit the
but
beard.
I didn't want to kind of like take a bet on that.
There is
Uh,
I have a fan that usually comment about my hairstyle in our video. So hi.
so maybe if we reach 1,000 meaningful comments and 50,000 viewers, Matteo is gonna get a nice mohawk cut, shave on the side.
Look, I don't think that's going to happen because that will need to require a way more to pay for the divorce. But this is
I will personally be your hairdresser with my cutting machine. I'm gonna
okay.
start going on YouTube and learn. But yeah, today I think we are taking one step further in our conversation about these modern architectures.
Yeah.
And by the way, I had the beautiful chance to connect directly with some of our listeners, and it seems that everyone is really enjoying this kind of like ride that we are taking into the world of modern composable architectures and platforms. But that today, so we thought we spoke about many things, and I think today was the time because we hinted last week with the platform about the runtime composition, so the kind of like missing variable in all these equations. So and we are in this journey, just for everyone that may be tuning in right now, or anybody that doesn't want to listen to the previous episode, or they're listening with a shuffle. We are talking about composable architecture, so the modern enterprise way of building applications with API services and integrations, databases, and all those kind of things. So we are kind of like taking a ride there. But the question is, we spoke about composition so many times, and today the question is, but what about composing at runtime? Maybe what does it mean? What it is? What are the downfall and good things about it? Where do we start?
Oh, I want to start with. Okay, I want to recap a little bit the status quo of things. Okay, what you will see on most enterprise and companies these days. Okay, you probably see a network of services or microservices. The core, the actual how much they are fine grained or coarse grained, really it's irrelevant. But you see a network of those. Okay, can have 30, 50, 60, 100, 200. Okay, they talk to each other. They are written in multiple languages. Okay, some of them are pretty legacy things, some of them are relatively new things. Okay, and there is an evolution and a stratification of different things all the time, right?
Yeah.
And a lot of the interaction between those things is often mediated by what is called a mesh network, which typically runs in Kubernetes or analog, that essentially allows service A to talk to service B, but more or less programmatically. So you can say that only service A can talk to service B and these kind of things. It also handles like other concern of security, logging, distributed tracing, can do all sorts of things. And usually those things also add overhead. There is also very often a load balancer in between. So in reality, from service A to talk to service B, it also passes through a load balancer. Okay. All of these in the name of two things. Okay. The first problem is, I want them to scale independently. Okay.
Mm-hmm.
And the second one, those two services are developed by two different teams. Okay. And therefore, I want the two teams being independent in deploying things. Okay. There is also the third case, okay, which is the services are developed by the same team. Okay. They more or less scale the exact same. Okay. And they implemented microservices because it was cool.
Yeah, and I think there is, I was chatting. Okay, I need to. My brain needs to reconnect. Because
Do you still have a brain?
I still
after
have
all the after all the traveling.
I always so yesterday, right? Yesterday, yeah, yesterday. I was talking with one of our listener. I had the beautiful chance of connecting with them, and we were just talking about exactly what you just said, like the methodology of building applications to follow not really the system or application need, but mostly to follow what the company feels is good, right? In terms of like the one of the pillar that is people. And so we were talking about the composable monolith. That says what you were hinting. And it's kind of actually funny how there are two faces to this medal. On one side, you have the enthusiast of, the people that can basically distill what is really needed, and the other that they kind of like follow a train of trends, right?
Which is
pretty normal. But what actually was kind of interesting, to your point, is that once that you kind of like follow the same line of thought, and you think, what shall I do? Shall I design for my team, or shall I design for scale? Shall I design for what? You pick one or the other, right? And but at the end of the day, and that's what I think it's super cool about what we discussed today, is this kind of composition. Is that I think composition is a workflow, is a factory chain, right? On our, for example, an assembly line. And it's kind of interesting, like to see how we are even moving from a world where everything was statically composed to a world where things are developed distributively, and then runtime composed, which is kind of like pretty interesting to see this kind of like flow.
So I want to go back to the two good cases. So one case is I just follow the hype. Okay, you follow the hype, you deploy multi, you have one small team doing microservices.
Yeah.
Then you eat I want to cover that case first. Oh, the light went out. Dang. I didn't charge it, so that's the problem. And I'm sorry, we are not going to get the green today. Let's see. Just a second.
And this podcast is not sponsored by the company making the light.
Sorry about this, guys. I am.
But it's kind of interesting because I think it makes it very real.
Yeah. Well, it's let's get the lights on. Okay. And here, okay. And I got the green back.
Don't drop it before you break it.
Okay. Here you go. Green is back. Okay. So, okay, so I want to talk about the hype case first. Okay, when does it manifest? When a microservice architecture is complex to manage when it runs in production. You need to have a lot of more monitoring, more distributed system, more observability built in. Your team is small, okay, and you have a lot of incidents, and you don't know what's happening in the system, and you feel essentially overwhelmed. And typically, these are the typical, flags that you see when you see that kind of system. Okay, I think these conversation, the last few conversations of our podcast, have been for you mostly. So, anyway, going back of the other two cases, this is the first case, and we just say, well, whatever, this thing can be improved. For the other two cases that you decided to split the system based on two trends, one is scaling people, the other one is scaling hardware. Okay, so I want to talk first about scaling people, because in all enterprise that I've seen, this has been probably the 99% case. Okay, literally scaling people. Okay,
yeah,
it solved. They say that microservices solves a logistical complexity problem. Okay, it shifted complexity from having multiple people working together in the same code base to having multiple people interacting with known APIs outside of the same code base. Okay, so I want to cover that case. Okay, and that's the case that we are covering here. Scaling, if you need to choose things that scales differently, okay, probably it's good that they are managed differently. Okay, typical example is I have some normal get routes, okay, get, post, and so on, request response interaction, and soft real-time, pseudo real-time servers, okay, for example, like WebSocket, SSE, these kind of things. Okay, if I have those two behaviors implemented on the same server, those two patterns, those long-running connections are completely different in terms of scalability versus the first one. Okay, now that creates some dynamics in your server in terms of what is garbage collectible, how the connection are going to evolve, and so on and so forth. That makes it more complex for the system to handle them at peak efficiency, okay, when you mix them together. So apart from that specific block, and that case makes some sense, and we will cover these too. But I want to say this is where scaling differently actually makes a lot of sense. Okay, now regarding scaling people, okay, the problem, you have been told that the only way to do this, okay, was via Docker images, Docker containers. Okay, some people might have saved AWS Lambdas, serverless, and so on and so forth. To all intended purposes, for that specific part of the discussion, they are the same. Now, you can run them multiple things, okay? But the question now is, how do you combine them, okay? Because you have these things running, okay? And you have different pipelines, different deployment infrastructure, different containers. You have 100 of them, okay? And, and they more or less scale the same too. So, if you need 50 of one kind, you probably need 50 of the other as well, because at that point they are, they more or less scale all at the same time because they provide the same service on the same line. Plus, there is a plus. And I want to inspire myself from a tweet I've seen from Devin Eamon Anderson that done a few days ago on microservices, and said every single microservice you add on your chain, you lose a 9 of availability.
Is it true? It is absolutely true.
Okay.
Even more probably.
So why is that? Why do you lose availability by adding
because you add fragmentation, and when you add the fragmentation, you add risk, ergo your availability statistically lowers. Is basically the same concept of how you started, right? The false promise of microservices.
But the problem that they are born to solve, the logistical problem of managing people and teams, is still there. So,
but it's not true, I think, because they assume a one-on-one relationship between people, feature and deployable, but it's not true. It's absolutely not true. Because a feature team, their target is not a deployable. Their feature team, the feature team is a functionality for the customer, right? Or whatever customer it is for a user, right?
Yeah.
So I think to be honest, DHH was even conservative in say you lose 1.9, but it's true. It's becoming an exponential problem. The more you add, the more exponentially and statistically you are adding risk to your system.
Wow. So if I have 6 microservices and I've not implemented any circuit breaking or any fallback pattern, what's going to happen?
Well, first, let's start with one thing, that a service mesh in general doesn't actually provide circuit breaking logic. It's an after-the-fact thing. Good note to all the service meshes around. Good that you provide the security and compliance, but fundamentally is an after-the-fact function and not a runtime function that they can provide. So,
so when you call a microservice from one microservice to another, you always need to make a decision to create your system so that other partner could go down at any given time and handle that logic gracefully in your application. And most enterprise applications that I've seen, do they handle this correctly, Luca?
I give you an example there. I give you an example here for everyone, and I hope that somebody from this company is listening, or else we're going to make sure they will listen to this. I'm booking the travel to where we're going to see each other to visit this customer.
Ooh,
which is a multiple leg trip, and that's why it's complex. It's not a two-way trip. So I went on Air Canada against my own will, because that's the only decent, let's say, connection and the timing aligned with everything. Anyhow, so it's a 3-leg flight, all one way, right? But because you buy them combined, they make you the single leg price, right? So now I tell you where it's funny. If I put 3 flights, it gives me an error, and they say try again, and thanks for helping me figuring out which one of the 3 legs fails. I buy 2, and then I buy a separate one, right? That could be a workaround, right?
It's also risky if you miss the first 2 are late, but yeah.
No, because are on the different days, right? So you can't.
Okay.
But so it's called multi-city.
I have a fear.
The funny thing is that it fails on the payment. But then you open the console and you know that it fails on something else, but they found it in the payment. So, and I know for sure that Air Canada, and you're listening to it, or you will, like zombies, went into this microservice thing without thinking that the checkout cannot, either is a unique transaction handling a workflow, or learn how to make fault-tolerant systems, because then you lose business, right? I mean, this is a real thing, and what you said, I think, is super important, Theo. It's super important. Like the complexity of runtime composition, which means even transactions, right? I mean, having transactions spread across.
Yeah, it means everything. It means when you're building a product that is composed of multiple parts, you need to make sure that each individual parts can function independently as much as possible, so that the core experience of your product is not impacted.
Yeah, and if you think about the going back to, let's say, the primitive, right, where it started. So where do you see actually, like, because the microservice, they came with a promise, right? Oh, you can run one service in Java, the other one in PHP, the other one in Node, the other one in Ruby, the other one Bash, whatever, you know. But is that really a limitation, you think, or an advantage?
I think it's both. Okay, it's if you don't do that, okay, you are going to get a lot of angry developers, okay, which you can, start throwing every now and then to kill, the pigs. Sorry, this is a bad joke of Angry Birds. And you have angry developers that they can't use their favorite tech stack. So they're very angry. Okay. And so you want to have the possibility to have multiple tech stack, also because some tech stacks are better at certain things than others. Okay. It's very notable that if you need to do a lot of machine learning or number crunching, your data scientist will get that written in Python, for example, okay? Because that's what they know, okay? So, and once they cooked an algorithm, okay, and they prepared an algorithm and it's written in Python, would you change it and port it into another language? Okay, like the only company that I've heard that does that is Tesla. Okay, that they write the algorithm in Python and then they port them to C++ to run the cars. But look, they have a very specific use case, running the thing on the car, okay, with limited and known hardware. So anyway, in the most cases, though, most companies will essentially try to keep that those scripts identical and run essentially those algorithms as the data scientist produced, for example, as is, and that means that you have some Python code.
Yeah.
And you need to put that Python code somewhere, okay? Another typical use case that I've seen many, many times is a company wrote a PHP monolith in 2012, 2013, 2014, something like that, okay? And then they said, oh, but we need to, we can't hire anybody to do PHP front-end because most front-end developers now do React and these kind of new techs. Yeah. And now we need to add a modern front-end on top of it. How can we get that done? And a lot of complexity starts, essentially.
Yeah, and then you cannot really compile a single bundle, right? You cannot actually pre-compile it. Then it has to be done at runtime. Because you have your Next.js application, for example, with your WordPress headless.
Oh, but you know what you do, what people would start doing in those scenarios is they will use many containers with different kind of stacks in them, and they will go back into the complexity that we just talked about. Okay.
And we actually kind of we really flew over, but the reality is that these containers are going to be, so there are two ways, there are two patterns, right? Let's also say that I can have multiple containers and I can still deploy them under a single, let's say, macro container using layers, right? So the so-called sidecar. You can call it sidecar pattern if you really want to kind of push it. But normally you deploy them as independent executables, right? Containers, and ergo you're through the network. You are on the network and through the network for this communication.
Yeah, it's also, you're typically, in most cases, while in some cases Kubernetes can do some magic and have them running on the same physical host, you are still passing through a lot of layers of TCP proxies, indirections, load balancers, and things like that, which add latency and overhead overall.
And complexity, right?
Yes.
In debugging and so on. And there is another thing, that the sidecar pattern breaks actually the logic of what service mesh can provide in terms of authorization and command and control. So the thing that I personally feel is pretty interesting is that probably, you know, what Java was doing at the time was not so bad, right? You develop all your stuff and then you throw them into a single place that is going to take care of, like, make sure that all these jars, they work with harmony inside of that context. But it's not really a one size fits all, right? I mean, you can do it for many things, and for other things, no. For example, you know, one of our user customers, Pendesk, did this experiment after we kind of challenged them, right? And they did this experiment. The result was astonishing. You know what we should do? We should actually, let's do something. Let's try next time to have Rob and tell everyone their experience. That would be.
Let's do that.
Let's ask Rob to tell the thought process and so on, because sometimes it just feels that you and I are like chatting and it's our own opinion, and people, they're just like, oh no, but the entire world does something different. And magically we discover the entire world actually loves it because, you know, they feel challenged, they try and they debunk and demyth years and years of like a status quo. So let's bring Rob and let him tell the story.
So the part of part of what we did, what we developed, okay, when we made that realization that all of these were problems, was to say, oh, how can we fix this? Okay, and we tried a lot of things before we settled on our solution, right, Luca?
Well, the market had already WASM as some sort of like a universal alternative, right?
Does it? Is it?
It's BS. No, it's BS.
Well, this is a long I have yet to see that reality fulfill, that promise fulfill. Okay, I've not seen it yet. I am not going to write it off, but so far I have and by the way, I disagree on that direction of WASM too. So I disagree on the direction.
I think for me the proof is here, right? I mean, I remember there was this famous API gateway that you could only write plugins in Lua, and the world was clearly saying, "What the heck? Lua is just for video games and for graphical tools." And there was a transitional time when basically they tried to run WASM, and they tried. Oh, this is you can write JavaScript, you can write whatever they want. I don't know. Have you ever heard of any progress there? And it was many years ago, a few years ago. No, it's because the reality of facts that, for example, when let's use a very simple example, Theo. We started our assumption in rewriting the Kafka client, say we write it in Rust and it's going to be faster.
Yeah.
Right? Didn't we start with that?
Yeah.
What reality told us after a week
that was not the bottleneck.
That was not the bottleneck, because you still are facing in all these systems that are purely structure-based and structure-intense. Because at the end of the day, TypeScript, and I'm talking to you guys, brought back structural form to the way developers think, right? So types has also have a cost that everyone knows when you go cross language or you go cross runtime, is that they need to be re-represented in memory, right? Correct me if I'm wrong, if I say something stupid.
It's not related to TypeScript though, but yes, you have.
We are talking about kind of like
But
right?
the same
like
problem is when you're moving one object from
.NET, anything.
When you cross the network, when you cross language, when you cross any barrier, you pay a cost.
You pay a cost, the so-called marshalling cost, or boxing and unboxing when you are in managed languages like .NET, like Java.
Yeah.
And so it costs you more. You pay a tax on it. It's like when you buy stuff in North America, that the price is without tax. So you go there and say, "Ooh, it's cheaper." No, it's not cheaper. You pay the tax. That is, what is on top. And I think on the other side, when you are in your own language, in your own scope, like JavaScript in this case, .node, it's like being in Europe. VAT is included, right? It's a very honest, like I like to explain it to people in this way because, it's very real, right? What you see
It's
is what
not,
you get.
to be honest, is not that marshalling and unmarshalling is always bad. Okay. In some cases, for example, in the model that Erlang has and other system, the fact when you communicate between different actors, everyone get a full copy of the data, and it adds safety at a cost. Okay, that's what I'm saying.
Yeah, but that's the same. For example, at the time in WCF in .NET.
Yeah, exactly.
But,
No, but it's the same
but
practice. But it's. I just wanted to mention it that it's not necessarily bad. It has a cost, but it's not necessarily bad. It's
Elixir, for example, is super powerful, right?
Yeah.
It's very, very powerful. But this is a language that was designed around this concept, right? It's basically, if you think about the use case, this is the perfect use case for which you use Elixir or Erlang. By the way, for everyone listening and interested, I want to do a shout out to a person that we both admire. But many, many years ago, back in 2012, so we're talking about 13 years ago, GitHub actually had this beautiful talk, Tom Preston, on the way they actually did it in GitHub with in Ruby, rebuilding some of the Erlang primitives. And they show exactly what we are just saying today. Tom Preston already solved it, between quotes, or like found a solution many, many years ago with Ernie, Chimney, beautiful things that they probably now are obsolete, but for anybody interested in some vintage, phenomenal mad science, I highly recommend to go and check them out. Hopefully Tom Preston will also retweet our shout out. I'm just saying. But yeah, and by the way, when we were talking with him, you remember in Pontresina that we were on the train, and I told him about that. He was surprised because probably there are only 5 people in the world that really watch it. But there was this beautiful interview that I cannot find anymore, to be honest, where he explained everything in details. And actually, GitHub was solving for this problem, right? This kind of like a massive distributed intra-hop communication, right? And it was super, super, super interesting. Sorry for the parenthesis, but it's something that I'm nostalgic and I love. But yeah, so all this kind of like runtime and different kind of like extra runtime communications. But so Theo, going back a little bit to like the developer angle, right? Because I don't know if you remember, but when we spoke about CQRS, some people rightfully commented that there are frameworks in other languages to do CQRS. It's my opinion, it's not Matteo's opinion, so I take responsibility. If you need a framework to build an architectural pattern, for me, there's something wrong because architecture and frameworks, they are not really kind of like, to me, similar things, but, it's my own opinion. But in this world of like modern composable systems, and, you see a lot of this, distributed communications, right? Well, where are we with frameworks and so on? Like from a developer standpoint, where do you think a developer should start? Because we know that this is going to be a question. So what kind of framework should I use? So let's answer it before the question comes in.
First of all, the framework in which you are most productive in to ship things faster and fulfill the business. Okay. So, and that is always, should always be your driver if you are on in any company. You have business goals and you need to fulfill those business goals in the best way possible. Typically, this involves being productive. Okay. In some cases, you might want to decide that the framework you're going to use is for the sake of others. Okay. For example, if you need to using an esoteric language, an esoteric stack, okay, might help in adding talented engineers. Okay, it will also create huge pipeline problems for hiring a lot of them. Okay, hiring will become much more costly for you. So the framework, when you choose a framework, you need always to decide more or less between how many people are there, the community of that framework, okay, how big that framework is, okay, and what kind of support you can get from the creators of that framework, okay, and what is your company appetite for novelty. Now, this really doesn't mean anything to some extent, okay, because if you are a developer, I didn't answer your question. So for me today, if I need to choose how to write server-side rendered applications, okay, I will probably recommend a company or a company that does not have any other opinion to go with Next.js, okay, mostly because that's the thing they teach in every bootcamp, in every course, okay. So very simple, okay, for building your front-end bits, okay. Then I would recommend to use something like Fastify to create your API, and I will be very adamant, okay, to have you create your APIs and emitting, your APIs JSON schema, okay, not any other languages or format that you can think. JSON schema or GraphQL, okay.
And Theo, you mentioned GraphQL. Sorry for interrupting, because I think that's a good thing.
Yeah.
We talk about runtime composition. So is GraphQL the right framework for runtime composition?
I think that deserves a full-blown section, a full-blown podcast, Luca, on that topic. I have opinions, strong opinions, okay, motivated opinions after implementing 2 solutions for that, okay, and I can more or less conclude on some good things. So
we pin it and we're going to talk about it. So for anybody, we're going to
let's pin it. We're going to talk.
Shall we do it, Theo, then before the summer break?
Maybe we'll see.
Can maybe listen. Let's see. But sorry, I didn't mean. But you said GraphQL, and I know that somebody might.
Yeah. So okay. Anyway, going to the topic. Okay, what you want essentially to have a language for your APIs.
Yeah.
That is technology agnostic. Okay, it represents your API in a technology agnostic way. I'm not a fan, but you can pick gRPC. gRPC is okay. It's not bad. Okay. I'm not a fan.
You said gRPC, not ERPC, right?
gRPC, yes.
Or with the G of Genova.
Yeah, of Google. The G of Google.
Okay. Not the one of Toronto.
Yeah, no.
Terrible.
Generically, okay, like my opinion of tRPC is that it works really well if you are a solo developer or a tiny team with absolutely no ambition in growing in size. Okay, at any bigger company, it solves some very specific problems. Okay, very well. It's great for that use case. The moment you exit that use case, it's not the right tech. It's even written in the README. It's not the right tech. Okay, like so but unfortunately, a lot of medium to large companies are in that box. So specifically because you want to, an application written in Python, Go, Java, whatever, be able to call you. And if you are using a wire format that requires that you share the same client, the same code between client and server, that's not going to happen. And this is a...
I'm not naming the company, but there is a startup that closed Series A and so on, that actually built around this kind of like philosophy their business, which I think is completely terrible. And I'm very honest.
Yeah, look, I look, wrote the name, Luca. If we ever start, if we ever get some friend in consulting, we can recommend them to unravel that thing.
Yeah. But I think you have a completely great point, right? Because if on one side, this type of architecture tries to decouple from consumer to producer, the relationship, and they do runtime aggregation with technologies like whatever. This is an anti-pattern, right? Because you're basically now tightly coupling the two things.
Yeah.
Right? So many people would say it's a contract-based communication, but I think honestly, what you said before, use OpenAPI or JSON schema.
Yeah,
that's stronger than anything else, because it uses a protocol which is completely standardized.
Exactly.
Right.
Exactly. Come on, you want a protocol that is standard, okay?
And I personally feel, just not to sell our own things, but we took an approach which is fundamentally a purist approach on how, for example, you do the intra-process communication through HTTP, right?
Yeah.
So we took the spec and we said, are we breaking the spec, yes or no? And we said, what is the protocol? What is the transport?
Yeah.
And I think that many other languages or frameworks, call it as you want, I think those ones are just like frameworks, forces you to do the opposite. We standardize on the protocol, on the transport. We force you on a certain transport, and the protocol is completely custom baked in a binary format or whatever you want, which is, to me, not good. If you think gRPC has a different approach, right?
My problem with gRPC is debugging. Okay.
Well, yeah, you're basically
like if I need to call a gRPC service, I need to have, I don't know, use some tool, load up that definition, call using that definition. It's a lot of it's a lot of work. If I need to call an endpoint built that just speak HTTP and JSON, I can just use curl, which is super straightforward too.
Yeah, and just because I know the answer, but I would love you to elaborate. With GraphQL, where are we? Are we on the right or on the left of this spectrum?
It's like GraphQL. It's fantastic, okay, because it sits. It's a little bit more. It's more complex than REST and JSON. It's still REST and JSON, by the way. Okay, GraphQL is REST and JSON. It's a protocol built on top REST and JSON. Okay. But the problem, the greater thing about GraphQL is it allows massive flexibility at a huge cost, computational cost. So huge flexibility, high flexibility, huge computational cost. If that's it's a good trade-off.
Yeah.
It's a good trade-off. You need to know when you're choosing it, you need to know that you're choosing it for that. Once you know, you're great. You're golden, because you know the trade-off you have made. If you decide that, I made a mistake and they didn't really want to do GraphQL, like I don't really like the trade-off that I've made. Well, you made the trade-off. You didn't, you didn't read the clause in the tiny clause in your contract with the devil, right? It's
to me, honestly, Theo, and I don't want to steal the discussion we'll have later, but one pin that I will put in the GraphQL is that, probably let's write it down and we can unpack it in our next chat. But isn't it the same thing as at the time, you remember the big OData movement on top of like SQL Server and so on.
Yeah, it's more or less. Well, at least that is standard. GraphQL is standard, so that's good.
Yeah, also data. I mean, was
yes, but
an
less.
attempt of being standardized. Yeah, less because. Yeah, well, I mean, we can unpack it in our chat, but I think what we maybe the question we will answer in that conversation is that are these type of technologies, do they deserve to be a shift right or shift left towards the consumer, right? They need to be the edge communication or maybe something behind. I don't know.
Yeah.
That's for later.
It's a long conversation. So anyway,
yeah.
Going back to the composition of services, okay?
Yeah.
Now, we have unpacked this. We know that when you're networking your services, okay, you are lowering your availability, okay? You are increasing latency. You are increasing risk, okay?
Yeah.
However, you can move your systems, your application at a higher, develop more features, having more people working on them, and so on and so forth. Or you can have wildly different scaling patterns in case you need them, okay? Perfect. Now, looking at this problem, though, it's a fundamental. Now, however, there is one thing that we have not talked about, okay, which is the moment where you need to make that decision, okay? Unfortunately, in most of the technologies and companies that you look at, that decision needs to be taken very early, and changing that decision has a very high cost.
Yeah.
But you typically make that decision more or less looking at the sky, trying to find where the wind will blow, okay, without any real data, any real information. So essentially, you are clueless about the decision you're going to make, okay, and you can't do anything.
Yeah.
Now, there is this infamous paper from Google that we mention almost in every single instance of our podcast.
And we don't get a penny from Google for mentioning.
Perfect.
Actually, they bill us for GCP.
So in this paper, it shows how the architecture that they're using internally to compose multiple microservices into the same binary, into one single binary that then they use to deploy. Now, that pattern is great, okay? Because if I have 3, 4, 5 things together that are similar in shape, in terms of how I want to scale them and so on and so forth, I can squeeze them together, okay? By squeezing them together, what do I get in return? Okay, I get better availability, lower latency, okay? Those are still developed independently by the team.
Yeah.
And more importantly, I can postpone the decision of my actual physical architecture of my system to the last possible minute. And I can change them by typically the flip of a switch. Like I say, okay, I can take this thing, move it in another bit, and all the transporting, all the communication will still work.
Theo, I know that we are at time, but I have an idea.
Yes.
Are you open to listening? The answer is yes. You know what we should do then next week? We should take. I used to do it at Talos, this thing, and it's a white paper reading. We are gonna take the white paper that we mentioned basically in every episode, and together with Rob, let's go through the paper.
That cannot be a bad idea. Yeah, let's do that.
Try to basically see if that aligns with some of their findings, and try to basically share the experience of taking Google on one side and on the other one, somebody that kind of like tried something different, and see if the reality confirms the initial assumption that even Google did. And let's do that. So next week, for everyone listening, you will find a guest, and we are gonna do something a little bit different. We're gonna banter on somebody else's white paper and try to basically see if the myth is debunked or is confirmed, like Mythbusters. It's going to be a special Mythbusters episode. Let's do it.
Let's do it.
Thanks, guys. Thanks, Theo. It's always a pleasure.
Thank you, Luca. It's been fantastic.
Ciao,
bye,
everyone.
Bye. Ciao.